All right, I wanted to make a video quick of a couple things we had to skip the other night. So this is our in section 2.6, and it's that explore problem, which normally I'd have you do in a group. And so it was the one whether if you do 10% first, followed by 5%, is that the same as 5% followed by 10%. Now, that's a different question than asking if that's the same as 15%, which is kind of the question we've had in the past. So again, $100 is always a good number to try, so if you're not sure. So if you take 90% of that, because you're keeping 90% if it's 10% off, that would be, what, $90? And then if you're doing 5% off, that would be the same as keeping 95 of it, right? And so if I do that math, let me grab my calculator quick, that would be, what, 85.50? All right, so I'm trying to compare here. So if I do the 5% first, I would be keeping 95% of it. And you could just focus on the discount too to see if the discount is the same. So I would pay 95, but then I have my 10% off that, which means I'm paying 90%, right? And so if I do that math, I am also at 85.50. And let's see, sorry, 85.50. So if you notice, that doesn't really matter. And if you think about it, this problem is what, 100, and then we took 90% followed by 95. And you could even put parentheses saying we did that first. Where over here we did 100, and first we did 95% followed by what, 90. And so we have a couple properties that can help us out here. One, I could just group it differently. So if I'm like, well, you know, I'd rather group it differently, I mean, I could figure out the overall percent if I wanted to by multiplying those two together. So let me see if I did that on my calculator. Oh, if it would actually work here. Where am I at? So if I did 95 and then 90, that's really, you know, 0.855 times that, and I can get the answer that way. But I can also move things around to actually show that these are really the same. So if I wanted to, I could just switch the order of these two things over here because of commutative. And so then you can kind of see like, oh yeah, mathematically those really are the same. All right, so commutative, you can move things around as long as it's all multiplication, all addition, and if not, then you're kind of out of luck. All right, so let's kind of look at the next problem there. It says part B, will applying the 10% discount then, and then getting a 5% be the same as 15? So that's kind of questions like we've done in the past where it's like, all right, so you have a $100 item, and you do the 10% first, which means now you're at, what, 90 bucks, right? And then after you do that, you do the 5%, which, okay, so here's my dollars. So now we do the 95. Which is exactly what we did before, which is what, 85.50, which is fine. All right, but is that the same as 15%? So if I do 100 times 0.85, notice that is what, $85? All right, so those are not the same. So doing 10% first, followed by 5% second, is not the same as 15%. So that's kind of what we've done before. If you're like, wait a second, I thought those were, you know. So this is a problem, but just doing 5%, then 10%, or 10%, then 5%, that's the same. But telling me that 10 followed by 5 or 5 followed by 10 is 15%, that's the part that's a problem. And again, if you're not sure, you know, just pick a number, do the math, see what happens, and you should be able to figure it out. Next page. Just remember that if things look alike, then you can add or subtract if they don't. But sometimes it's a little tricky, like AB plus BA may not look the same. But in reality, one of them is a rectangle that's A by B. The other one is a rectangle that's B by A. Those are literally the same shape, okay? And so I have two, and usually we do alphabetical order, 2AB. And then same thing if you had AB minus BA. All right, so you have AB, and then you're just subtracting the rectangle BA. Notice they have the same area, so when you subtract, you're just going to end up with 0. And so usually when we group things, we are using properties like commutative and associative and things like that. All right, let's see. I'm going to come back and erase quick. Let's look if there's anything at the top of the next page. So just as far as using associative deals with grouping, like who your friends are. Commutative deals with commuting, like those of you that commute to work or to DMAC from where you live. That is obviously commuting. And so it's not just in algebra. I mean, obviously we wouldn't have algebra without some of these properties, but it's just real life. You know, if you have something really ugly, sometimes if you put the order in a different way, things might be a lot better. So for example, if I have this and then I have a 4 out here, I don't really know what that is, but I'm like, ooh, if I could just move that 4 over there and group that, then that would be 100, which is nice. So there I'm kind of moving and grouping, so that would be commutative and associative, so 1700. Sometimes we just want to move the order, so you have like, say, 99 plus, oh, I don't know, 347, and then a 1 over here. Well, you know, it's silly to go left to right, which is what order VOP says, but you're like, well, can I just move these guys? Can I just switch the order around? And then you're only commuting. And then you go left to right and you're like, oh, wow, that's 100 and 347, so 447, which is very nice. And again, sometimes we just group. So say sometimes you have, oh, I don't know, like say 99, let's see. Oh, what would be grouped? Let's do it this way. Say I have 48 plus 99 and then plus 1 out here. And I'm like, well, you know, I'd rather group these together. I'm not moving anything, but I'd just rather group these together. So then I can get my 100 there and then add, I don't know, well, I can't remember what I said. We'll pretend it's 98 and get 198. So sometimes if you just deal with grouping, you're dealing with associative because who you associate with is who your group. And then if you're dealing with movement, you're definitely dealing with commutative. And sometimes you do a little bit of both. And then the next section was just talking about the distributive property. And let's see, I might not have erased down here, so I might have to erase a little bit. But that intro problem there that we didn't have time for talks about, is it okay to add them up and then do the tax, or do you have to do the tax on each thing? So if you're buying something for $13, $73, and $27, can you total it first and then do 8% sales tax, which this would be the money with the tax? Or is it okay to do the tax on each one? Well, notice that would be distributing. So you do tax on that item, tax on that item, and tax on, oops, that's an 8, sorry, the last item. And if you do the math, this answer, so if you get the total first and then do 108%, that would be your total bill. Or if you do tax on that with the price, tax with the price, and tax with the price, if you add those up, you actually will get the same answer. So either way, you're going to get 122 and 4 cents. And so again, that's kind of like what I showed the picture with the goodie bags. I mean, the distributive property works because you can either focusing on getting the total and then dealing with how much of it you have, or you can deal with each individual piece and then total that up. So either one is going to work out fine. I'm trying to think if there's anything else. I guess one thing to be cautious of with distributing is if you have a negative, make sure you distribute it to everything. So again, like if you have, say, I don't know, x squared plus 2x minus a negative 3x squared plus 4x plus 6, make sure you distribute that to everything, kind of like a Pepsi truck distributor. Otherwise, you're going to get fired. So a negative, so you're oppositing this, which would make it positive. Oppositing that, which would make it negative. Opposite of that would make it negative. And then you can put cats with cats, dogs with dogs, and those are just leftovers. So then you can do your piles. So again, remember when you distribute, you got to distribute it to everything. And even if it's a number, you still got to distribute it to everything. So for example, excuse me, if this is a negative 2 and maybe we put an x in there as well, okay, I have to distribute that to everything. So now I have my, I have my x squared plus 2x, and there's nothing out front to change that. But then I get this guy, which is what? Plus 6x. Powers change when you create new stuff. You're multiplying. That negative goes with that one, and then again, powers change because I'm creating new stuff. And then this would be what? Negative 12x. All right, and then I'm going to do my cats in a pile. Oh, those are cubes right there. All right, so that would be like one of them, and I owe 8, so negative 7. Here I have 6 cubes. Put those up front, and then I have 2 x's, and I owe 12 x's. So what is it? Negative 10x. And we tend to write these things in what we call descending order, like the highest power, next highest power, and so forth. You don't have to. We have the commutative property, but that's just nice. So again, this, you can drop the parentheses because there's no math out here to do. Distribute, so you get a positive, powers change. Negative powers change. Negative powers change, except there wasn't any x. And then your cubes go in a pile, your squareds go in a pile, and your numbers go in a pile. And you should be good to go. All right, hopefully that helps. I know I wish we would have had more time in class, but at least we can use technology maybe to go over a few of the things that we missed. All right, have a good day and study hard.